You're welcome to class. From now onwards, we will be preparing you for exams, and there's no way you will stay with us or study with us that you will not smash good grades in your exams, because we'll be focusing on the areas which you need to know before you go for your exams. And the first topic we are going to discuss is the real number system. Okay, the first question we're going to start with is over here. We're asked to find the value of R if 6R7 to base 8 is equal to 511 to base 9. This is as easy as possible, but you realize that we have the left hand side to be to base 8 while the right hand side is to base 9. So the first thing to do is to look for a way to convert both of them to the same base so that we'll be able to work with them easily. And the common base we can convert them to is to the base of 10. So if you do this, you have 6R7 base 8 is equal to 511 base 9. Like I said, our first step is to convert each of these numbers to base 10. And how do we do that? Is just to assign a particular number to each of them. And in assigning this number, we have 0, 1, 2 and 0, 1, 2 over here. So after doing that, the next thing is to solve. So we have 6 times 8 raised to the power of 2 plus R times 8 raised to the power of 1 plus 7 times 8 raised to the power of 0. Then this will be equal to 5 times 9 raised to the power of 2 plus 1 times 9 raised to the power of 1, then plus 1 times 9 raised to the power of 0. And after assigning this number to them, you can solve them arithmetically. So we have 6 times 64 plus 8R plus 7 times, from indices, 8 raised to the power of 0 is equal to 1. That is, any number raised to the power of 0 will give you that same number. So we'll give you 1. Okay, so we have 7 times 1. Is that okay? We have 7 times 1, which will give you that same number, which is 7. So, which is equal to 5 times 9 squared is 81. We have 81 plus 1 times 9 and plus, of course, 1 times 9 raised to the power of 0 is equal to 1. So we have 1 times 1. If you simplify this further, we have 384 plus 7 plus 8R, which will be equal to 5 times 81, of course, is equal to 405 plus 1 times 9 is 9, then plus 10. So this gives us 391 plus 8R equal to 415. Of course, the next step is to collect the like terms. And how do we do that? Is to make sure that anything that is bearing or that has the alphabet, the dependent variable that we're looking for, is on the left hand side while the other one is on the right hand side. So we have 8R is equal to 415 minus 391. If you do this, we have 8R equals 14, and dividing through by the coefficient of R to make R stand alone, we have this to be equal to R equals 14 over 8. If I simplify this to the lowest term, I'm of course going to have 7 over 4 as my final answer. So if I check, which is my final answer? Of course, the answer is C. So this looks simple, but to some people it's still very complicated. This will take us to the next question, and I'm sure before the end of the next question you should be able to understand better if you're still having difficulty. So let us go to the second question. We have, if 2q3 base 5 is equal to 7 base 8, then find the value of q. I want you to take note that these are the bases. These are the bases. Okay, so solving this, just like we did in the first question, you have 2q3 base 5 equals 7 base 8, and I'm asked to find the value of q. The first step is to assign numbers to each of them, assign exponents, and these exponents are numbers to each of them. To do that, we have 0, for emphasis, 0, 1, 2, then 0, 1. If I simplify this, we have 2 times 5 raised to power 2 plus q times 5 raised to power 1 plus 3 times 5 raised to power 0, which is equal to 7 times 8 raised to power 1 plus 7 times 8 raised to power 0. This gives us 2 times 25 plus 5q plus 3 times 1, which is equal to 7 times 8 plus 7 times 1. 2 times 25 is 50. So we have 50 plus 3 plus 5q equal to 7 times 8 plus 7 times 1 is equal to 63. So if I collect the like terms and simplify further, I have 5q is equal to 63 minus 50 plus 3 is equal to 53. So we have minus 53. And this simplifies to 5q equals 10. Equals 10. So dividing through by the coefficient of q to make q stand alone, I'll divide through by 5 and divide through by 5, and q will definitely give me the value of 2. Therefore, my q is equal to 2. This looks very easy. Very, very easy. Now with this, I'm sure you understand what or how to go about this type of problem. Let us go to the next problem, and I am sure you realize that all these problems are direct exam question, JAMB 2011 question 2. So you can check that up to confirm if they are actually correct. Okay, so JAMB 2011 question 2. Let's go to the third question, which is JAMB 2012 question 2 as well. There's one thing I want you to note. It is not just about solving questions. You have to understand the pattern of the question. Now, the 3 years we have considered, let us see. JAMB 2010 question 2. Is that okay? The next question, JAMB 2011 question 2. I'm sure you're seeing the pattern and the sequence. The third question, JAMB 2012 question 2. Now this should tell you that you should be expecting questions on real number system between the range of question 1 to question 5. It's just a hint I'm giving you. Is that okay? They can decide to change it in your own time, but come on, anything that works for consecutive years might likely work in your current year. Okay, so just don't get it twisted. Take that as a very, very important tip I've given you. So convert 7 to base 6 to a number in base 3. I can't just convert directly to base 3, okay? I have to convert to base 10, which is the general base, okay? It is just like a reference base. Then from base 10 I can easily convert to base 3. How do I do that? Just like we've done in the previous questions. Let us convert 72 base 6 to base 10. To do that, I will have to assign my value, my exponent. So we have 7 times 6 raised to the power 1 plus 2 times 6 raised to the power 0. This gives me 7 times 6 plus 2 times 1. 7 times 6 is equal to 42. So 42 plus 2 is equal to 44. So I have 44 base 10. So I can easily convert 44 base 10 to base 2. And how do we do that? This step or this method is different from the ones we had in our previous question. Okay, now how do we do it? You just draw a vertical line straight down, okay, and a horizontal line crossing it like this. Then after doing that, you put 3 here, the base we are converting to. So we are converting 44 base 10 into another number in base 3. And what is that number? This is what we are going to find out very, very shortly. Okay, now how many times can 3 go in 44? Probably with remainder or without remainder. Okay, so converting 44 base 10 to a number in base 3. Okay, now the first step is to look for how many times 3 can go in 44. Okay, so 3 goes in 44 14 times, remainder 2, such that 3 times 14 of course will give us 42, then plus 2 will give us 44. The idea is once you multiply like this, if you multiply this way, you multiply like this, and the resultant value you add to 2, it must give you 44. All right, so if I continue that way, I have 3 goes in 14. How many times? Of course it is still going to give us 4, because 4 times 3 is equal to 12, and 12 plus 2 will give us 14. So the remainder is 2. Now if you do this also, continue till you get to the lowest value. If you continue, I have 3 goes in 4. How many times? Once. The remainder 1. So 3 times 1 is 3, plus 1 is going to give us 4. Then continue 3. How many times will 3 go in 1? Of course, is 0. Remainder 1. Remember I said the idea is if I multiply diagonally like this and add to this one, it must give me this value over here. So 3 times 0 is equal to 0 plus 1. It will also give us 1. If you want to check it, you just write it from bottom to top. And from bottom to top, the value is equal to 1, 1, 2, 2, then to base 3. So this is actually our answer. If I check, my correct answer is option D, 1, 1, 2, 2, base 3. Of course, all these are numbers in base 3. It's as simple as that. If I decide to consider the next question I have, which is JAMB 2013 question 2. It says I should convert 2710 to another number in base 3. That is 27. I told you this is base 10. 27 base 10 to another number in base 3. Just like we did in question 3, we have 27 to a number in base 3. So 27, 3 goes in 27 how many times? We have 9, remainder 0. 3 times 9 is 27. 27 plus 0 is equal to 27. So 3 goes in 9 how many times? We have 3 as well, remainder 0. Then 3 goes in 3 how many times? 1, remainder nothing. Then 3, 0, remainder 1. And of course, if I go from bottom to top, I will have that my final answer is going to be equal to 1000 base 3, which gives me option B as the correct answer. I'm sure with this, you're beginning to see the trend in which the question is moving. Okay, now this is JAMB 2013 question 2 also. So it has just always been question 2, question 2, question 2 like that. Okay, question 5. They said, write the decimal number to base 2. I want you to take note that whenever you come across decimal number, so we should write decimal number. Decimal numbers are numbers to base 10. So take note of that. Is that okay? Take note of that. So if anywhere you see decimal number, sometimes you might just put it as a number in base 10. Fine. But if you hear decimal or see decimal number, you know that they are talking about a number in base 10. So they've already converted a particular number to base 10 for us. And the result was 39. So we are asked to find or convert this 39 base 10 to another number in base 2. I use it as red because it is what we are looking for. All right. So a number in base 2. Fine. How do we go about it? Before we go further, I would like to know that every number whatsoever is to a particular base. For instance, the number 2 is base 10. Number 1,000,000, 1, 2, 3, 4, 5, 6 is to base 10. So any number whatsoever, the default setting is base 10. So they might decide to ask you to convert a particular number in its default setting to another number, or they ask you to convert from a particular number, a number in a particular base, to another number in another particular base. It's just like you're going from a point A to point B. Of course, you are going to meet some things on the way before you get to base to point B. Is that okay? So those things you meet on the way, just like converting that number to base 10 first before converting to base whatsoever you're asked to. Okay, so you can't convert a number in base 6 directly to another number in base 3 without passing through base 10. But in this case, they've already converted one particular number for us to base 10, which is 39, and we're asked to convert this 39 base 10 to base 2. How do we go about it? How many times can 2 go in 39? To do that, 2 goes in 3 once, so we have 1. Then 3 goes in 19 how many times? I used the organic method the first time so that you relate with it very well. Okay, it's just like saying 39 over 2. So 2 here 1, 2 here 1, remainder 1, so you put the 1 over here. So 2 times 9 is 18, so we have 1, 9, remainder 1. So 2 times 9, 2 times 19 is 38. 38 plus 1 is 39. So we are on track. Okay, so we have 2. 2 goes in 19 how many times? Of course, it is also 9 times. 2 times 9 is 18. We have 9, remainder 1. 2 again, because that is the same number we are converting to. So 2 goes in 9 how many times? 4. 2 times 4, 8, remainder 1. So 2 times 4 is 8, remainder 1 will give us 9. So we are still on track. So 2 goes in 4 how many times? Of course 2, remainder what? Nothing, which is 0. So 2 goes in 2 how many times? 1, remainder 0 as well. 2 cannot go in 1. That's why we have 0. Okay. Then remainder what? 1. Because the idea is if we multiply 2 by 0 and add to the remainder, it must give me 1. We are still on track. Okay, so if you want to write it, you have to write it from bottom to top. Bottom to top. So to do that, we have 1 0 0 1 1 1 base 2. And if I check my option, yes, I got that. That is option A as the correct answer. Option A. So you see that these stuffs are very, very easy to understand. They are not as difficult as you think. Or probably it's because Awoko made it very, very easy for you. Is that okay? So let's go to the next question, which is, we said find x. If x is equal to 1, 2, 4 base 5, then find the value of x. Okay, how do we go about this? I said the default setting is base 10. The default setting is base 10. So I have to convert this particular number in base 5 to base 10, and of course it's going to give me the value for x. Why? Because x does not have any number attached to it. Is that okay? So x, to solve this, we say x is equal to 124 base 5. Invariably, they're just asking you to convert 124 base 5 to a number in base 10. That's just the implication of what this is trying to tell us. If I do that, I would have 0, 1, 2, and x will now be equal to 1 times 5 raised to power 2 plus 2 times 5 raised to power 1 plus 4 times 5 raised to power 0, which is equal to 1 times 25 plus 2 times 5 plus 4 times 1, which is equal to 1 times 25 is 25 plus 2 times 5 is 10 plus 4 times 1 is equal to 4. So if you add these three together, we have 39 as our answer. So we have 39 base 10. So x is equal to 39. Now looking through the option, there is no option, there is no answer. Okay, because option A says 124, option B says 121, option C says 181, and option D says 180. So of course, I'm sure you know what to do. Once you don't have any answer there, of course the answer is none of the above. So with these, we have come to the end of the class, the first session of real number system. Okay, so if you still have difficulty in understanding what we've discussed, of course you can drop your questions on the platform, as our tutors are always there to attend to you. In fact, I'm always on the platform to solve your worries. So see you in our next class tomorrow, where we will discuss another topic, and trust me, you would not like to miss the class. So the same time, same platform, tomorrow by 3 p.m. we'll be discussing set theory. So see you in our next class on mathematics. Meanwhile, just exactly 4 o'clock, we will commence the physics class. So see you in the physics class.